Hi, in this video I explain problems with Formation's motors that have delayed production, how I've solved those problems and how the solutions make Formation better. The executive summary is that Formation is delayed to late summer, but at the same time Formation is fundamentally and significantly improved in several ways. The motor now lasts a lot longer due to a new feature which smooths carousel rotation. Changes to the control board firmware and the app mean that if the motor does need replacing, such as in public installations running the machine all day every day, any generic motor of the right dimensions and approximate RPM will work. On top of that, the app's speed control has been extended and improved so that it allows consistent speed control even with different motors. Now, please bear with me, some background is necessary to explain the issues properly. Formation is a boutique product. I won't make more than 200 units, so I can only buy motors in small quantities, and this limits the supplier options. A lot of effort went into selecting the right motor. I looked at motors from Pololu, Adafruit, SparkFun, Robot Shop, etc., but none of their motors were a good fit. All their motors of the right power and speed are planet gear motors and awkward to fit in the Formation frame, as well as being very noisy. Then I found these worm gear motors from China. The first motors I ordered were great. They were quiet and tested to well past 1,000 hours continuous runtime. So after the Kickstarter campaign finished, I ordered a bunch more. And in January, I started endurance testing these newer motors in the shop front display. Unfortunately, these motors are different from the ones in my first tests. They're constructed differently and they vibrate more. What I didn't realize was that buying small quantities of motors from China meant that each order from the same supplier could be different, with motors that are similar but not identical. Dimensions are the same and they're all spec'd to 100 RPM at 12 volts, but only approximately. The core construction, the gear ratio, the output power, and even the direction can vary. Even if I could afford to order 200 identical motors directly from a manufacturer to ensure consistency, I can't, because typically their minimum order quantities start at 1,000 and go up. The suppliers I found only sell in limited quantities and change the type of motors they sell according to what they can get. So back to the new motors. These particular motors run with more vibration, and after about a day in the window display, one of these new motors started doing this. The problem is that all gear motors have an amount of drift in the output. Now, to prevent the carousel acting as an amplifying soundboard for the motor noise, it's mounted to the motor with a soft silicon interface. In some cases, this silicon can act like springs at the drift zone edges, and this can cause the carousel rotation to enter what I call jerk resonance. In the worst case, this jerk resonance can become violent enough to cause audible gear grinding. I've been working on this problem exclusively since I finished the CNC setup. Of course, I started by looking for smoother running motors with less vibration, but in ordering from 9 different sources, I found 5 different types of motor, and I haven't found a source I can rely on for consistent supply of a suitable specific motor type. So Formation has to work and last with all of these motors, and with any other variants that might come up, making 2 problems to solve: stop jerk resonance and make Formation flexible enough to work with any 12 volt, approximately 100 RPM motor. Let's talk about smoothing carousel rotation first. This is the most important new feature. It stops jerk resonance and even improves the animation by dampening motor drift. The key principle is to apply a small, consistent amount of drag to the carousel, just enough to stop the motor wandering in the drift zone, and at the same time not significantly slow the carousel down or add a component that will wear fast. This is the solution. A curved spring wire drags against the underside of the carousel hub. For now, I'm calling it a drag widget. 2 symmetrically opposed drag widgets add a very small stabilizing resistance to the carousel rotation. To test the drag widgets, I've been running them in the window display 24/7. I started 3 weeks ago. They've been running continuously for over 500 hours now. I'm actually using 2 of the motors that alerted me to the jerk resonance problem in the first place. These are now running fine. The other 2 motors of a different type are fine as well. Reducing motor drift with a small amount of drag not only stops jerk resonance and smooths carousel rotation, but also reduces motor vibration, so I expect it also increases motor lifetime. I don't yet know if the widgets will help all motor types test past 1,000 hours like the original motors. That will take another 3 weeks. But the 4-window display machines are still running smooth and they look like they'll keep on going. There are 2 different gear ratios in the 5 motor types I'm using, and while I was working on the resonance problem, I was swapping motors in and out a lot. So I extended the code in the microcontroller and the app to easily configure formation for motors with different ratios, and for different animation lengths, for example 20 animation frames versus 16, and for different encoder setups, all using one number, counts per strobe. Formation works by timing strobes against on-off switch signals coming from the motor encoder. These are generated by a magnetic wheel with multiple alternating north and south poles. The poles flip hall sensor switches on and off as the magnet wheel rotates on the input shaft. This magnet wheel has 22 poles, 11 north and 11 south, alternating with each other. The poles generate 44 switch flips, or counts, per input revolution, as each pole switches the 2 hall sensors on the encoder board on or off. This motor's gear ratio is 1/65. One output revolution takes 65 revolutions of the input shaft. So for each output revolution, the control board is receiving 65 times 44, 2860, encoder switch flips, or counts. Excluding the Lego, our animations are all 20 frame loops, so we want to flash the strobes exactly 20 times per output revolution. The formula then for timing the strobes against encoder counts is the inverted gear ratio, so 65 instead of 1/65, multiplied by the encoder counts per input revolution, divided by the animation frame count. That's 65 times 44 divided by 20, which is 143. So the formation control board flashes a strobe every 143 counts it gets from the motor encoder. That is, every 3 and a bit turns of the motor input shaft, which corresponds to 18 degrees of revolution on the output shaft. The point is, the counts per strobe value lets you configure formation to run animations with different lengths and to use motors with different gear ratios or encoder configurations. I will of course ship all formation control boards pre-configured appropriately, but if you want to run an animation with different numbers of frames or switch in a different motor type, you can. Finally, I also changed animation speed control in the app. Previously, the speed control slider was just a percentage power level for the motor, but the different motors all have different natural speeds, and the same power level would run different motors at very different speeds, and I wanted to make it consistent. So I decided to link the animation speed slider to animation frame rate instead of motor power. Now, the microcontroller continuously monitors the carousel speed via the encoder signals and continuously adjusts the motor power to match the desired frame rate. This simplifies the control screen, makes the speed control consistent across machines, and hopefully makes it easier for everyone to get great footage of people reacting to formation with the strobes on. So, about shipping. As I mentioned earlier, I've been working on the motor issues exclusively for more than 3 months now, so while formation is hugely improved, it does mean another significant delay to shipping. Now, I expect to start shipping early birds in August, and it will take more than a month to ship to all backers. I do apologize. I appreciate some of you might have preferred I shipped sooner without a motor fix. But I won't ship something I can't stand behind. In the campaign, I committed to warranty formation for a year.